There's a 4-inch pipe sticking out of a hillside in Lancaster County, Pennsylvania. No wire running to it, no junction box, no meter. Just a black pipe pushed into the earth where a spring bleeds out of limestone, and clear water pouring into a stone trough that hasn't been dry since Eisenhower was president. Nobody turns it on in the morning. Nobody turns it off at night. There's no pump house behind the hill, no generator humming in a shed. The water just moves downhill through that pipe into the kitchen of a farmhouse where an Amish family washes dishes, fills kettles, waters livestock, same as their grandfather did, with the same pipe laid in the same trench, running on the same force that's been pulling rivers to the sea since before there were people to watch. You pay a water bill every month, maybe 60, maybe 90, maybe more when they raise it again next quarter. You budget for it the way you budget for gravity, like it's just a law you can't argue with.
But what if I told you there's a water system that runs on actual gravity,
Literally. And it hasn't cost a single dollar to operate in 7 decades. Not a trick, not a gimmick, not some off-grid fantasy that only works on paper. A real system on real land serving real families. And the question that should bother you isn't how it works. The question is, why did everyone stop talking about it? If this is the kind of thing that keeps you up at night, not the water, but the why behind what we forgot, then you already belong here. Subscribe, and let's keep pulling on this thread together. Let me tell you what this system actually is, because the name alone sounds like something a salesman made up. A gravity-fed spring system. That's it. No patent number, no brand, no inventor you need to credit. The principle is older than plumbing itself. Water on high ground flows downhill through a pipe to wherever you need it below. The engine isn't a motor, it's elevation.
the difference in height between where the spring surfaces and where your house sits creates pressure. The same force that makes a creek run is the same force filling that Amish family's kitchen basin. You don't plug it in. You don't prime it. You don't replace a part every 5 years and call it maintenance. The hill does the work. It always has. Now here's where people get confused, and it's worth untangling early. This isn't some secret the Amish invented in a barn. Gravity-fed spring water was the standard method for rural American households before rural electrification changed everything. Appalachian families in West Virginia had these systems running through the early 1900s. Vermont hill farms piped spring water into kitchens before they had telephones. Ozark homesteaders knew exactly where their spring eye was the way you know where your breaker box is. The Amish kept using it because they never switched to the electric alternative, but they didn't invent it. They just never abandoned it. And that's a difference worth sitting with for a moment. The anatomy of the system is almost embarrassing in its simplicity. You have a spring, a place where groundwater surfaces naturally, usually on a hillside or at the base of a ridge. Around that spring you build a spring box. That's a small enclosure, stone, concrete, sometimes just stacked rock with a wooden lid, that collects the water at the source and keeps out leaves, sediment, and animals. From that box, a pipe runs downhill. In the old days, it was galvanized steel. By the 1960s, black polyethylene roll pipe made it cheaper and easier. You'd buy a roll, trench it in, and connect. That pipe enters your house or your holding tank at a lower elevation. The height difference creates head pressure. 1 foot of drop gives you roughly half a pound of pressure per square inch. 30 feet of drop? You've got real working pressure. Enough for a kitchen faucet,
a garden hose, a livestock trough.
And the cost? Let's be honest about the numbers, because this is where the title earns its claim. Or doesn't. The build costs something. Pipe isn't free. Fittings, a spring box, maybe a day of digging or renting a trencher. Depending on distance and terrain, you might spend $200, maybe $500 if you're running pipe across rough ground. That's the upfront. But the operating cost, the monthly, yearly, decade after decade cost, is zero. Literally zero. No electricity, no pump replacement, no pressure tank, no well inspection fee, no bill. The water moves because the earth is shaped the way it's shaped. You're not paying for energy. You're borrowing geometry. And geometry doesn't send invoices. If you grew up anywhere near spring water, you already know something the rest of the country forgot: that water has a taste. Tap water tastes like what they put in it: chlorine, fluoride, whatever comes through aging municipal pipes.
But spring water, cold out of limestone, has a cleanness to it that hits different. People from Appalachia talk about this the way they talk about their mother's cooking. It's not just preference, it's identity. There are documented accounts of families in rural Virginia who refused to switch to municipal water when it arrived in their county. Not because they were stubborn, because they'd tasted both and knew exactly what they'd be giving up. That memory is part of why this topic pulls so hard. It's not just about money. It's about something that was better being replaced by something that was merely standard. But here's where I need to level with you, because this is the spot where a less honest video would gloss over the truth and leave you with a fantasy. Geography is the gatekeeper. You cannot build a gravity-fed spring system if you don't have a spring. And you can't get pressure if that spring isn't higher than where you need the water. Flat land? No good. Spring at the bottom of your property while your house sits on the ridge? No good. Dry region where springs are seasonal at best? Unreliable. And winter. Let's talk about winter. In northern Appalachia, these pipes freeze. Families had rituals for it. Some buried the pipe below the frost line. Some ran it through insulated channels. Some just accepted they'd be hauling water in January. This system works beautifully when the land cooperates, but the land has to cooperate. That's not a small caveat. That's the whole foundation. And there's a piece most people skip: water rights and legality. In some states, the spring on your property is legally yours to use. In others, water rights are a tangled mess of surface rights, riparian doctrine, and regulations that confine you for diverting a stream even on your own land. Western states are particularly strict. Before you trench a single foot of pipe, you'd need to know what your state and county allow.
This isn't to scare you off. It's to keep you from building something beautiful and then getting a letter from a bureaucrat telling you to cap it. The Amish family in Lancaster doesn't deal with this the same way because their community and their relationship with local governance works differently. Your situation might require a phone call or two before you pick up a shovel. So here's where we stand. The gravity-fed spring system is real. It works. It's been working for generations, and the operating cost genuinely is zero. But it demands specific geography, a spring, an elevation advantage, and land that allows you to connect the two. For a lot of people watching this, that's the end of the road. Your property is flat. Your water table is deep. Your spring, if you have one, sits lower than your house. And that should be the end of the story. Except it isn't.
Because there's a device, 200 years old, 2 moving parts, no electricity, no fuel, that takes water from a low source and pushes it uphill, using nothing but the water's own weight against itself. And that's where this gets genuinely strange. The device is called a hydraulic ram pump.
And the first thing you need to understand about it is that it sounds like it shouldn't work. Water flows downhill into the pump through a drive pipe. That part makes sense. The water picks up speed, builds momentum, and then slams into a valve called a waste valve. That valve snaps shut. And in the instant it closes, all that moving water has nowhere to go. It crashes into itself. That collision, that sudden stop, creates a pressure spike. Plumbers call it water hammer. It's the same thud you hear when you shut off a faucet too fast and the pipes bang in the wall. Except in a ram pump, that hammer isn't a problem. It's the engine.
That pressure spike forces a small portion of the water upward through a second valve into a delivery pipe, climbing to a height the water had no business reaching on its own. The whole cycle takes about a second. The waste valve reopens, water flows again, builds speed again, slams again, pushes another small gulp uphill. Over and over, all day, all night, no timer, no switch, no fuel. The rhythm is self-sustaining. The weight of the water resetting the valve is what keeps the cycle going. You can stand next to a working ram pump and hear it, a steady, rhythmic click, like a slow heartbeat in the ground. Joseph Michel Montgolfier, the same family behind the hot air balloon, built the first self-acting version in 1796 in France. By the mid-1800s, ram pumps were common across Europe and rural America. Factories manufactured them. Catalogs sold them. They watered hillside farms, filled elevated storage tanks, and supplied manor houses that sat above their water sources. This was not fringe technology. This was infrastructure. Now let me be square with you about what a ram pump actually delivers, because the physics are generous but not magic. A ram pump wastes water to move water. For every 7 gallons that flow through the drive pipe, you might push 1 gallon uphill. The ratio depends on the fall height versus the lift height. The greater the lift relative to the fall, the less water you get. So you need a source with real volume. A trickling seep won't cut it. You need a creek, a stream, a strong spring with consistent flow, enough gallons per minute that you can afford to let most of it spill past the waste valve. And you need at least 3 to 4 feet of fall from the source to the pump to get the cycle started. These aren't impossible conditions, but they're specific. A ram pump doesn't turn any property into an off-grid water paradise. It turns the right property into one. There's maintenance, too, and anybody who tells you otherwise is selling something.
The waste valve takes a beating. It's slamming shut hundreds of times a day. Rubber flaps wear out. Depending on your water's sediment load, you might replace a valve component every year, maybe every 2 years. The good news is the parts are simple and cheap. A piece of rubber, a bolt, a few minutes of work. Some homesteaders build their own ram pumps entirely from hardware store fittings for under $100. Commercial units run a few hundred to over 1,000, depending on size and build quality. And a well-maintained ram pump has been documented running for decades. Not theoretically, actually. There are units in Amish communities in Ohio and Pennsylvania that have been clicking away for 30, 40 years, pushing water up to hilltop holding tanks that gravity feed down to homes and barns. The circle completes itself. The ram pushes water up. Gravity brings it back down.
No wire involved at any point. So now you have the full mechanical picture. Gravity-fed springs for when nature gives you the elevation. Ram pumps for when it doesn't, or when it gives you a creek instead of a hilltop spring. 2 systems, both ancient, both proven, both running on nothing but the shape of the land and the weight of the water. And if you're like most people watching this, you've arrived at the question that matters more than any plumbing diagram. Why don't you know about this? Not why haven't you tried it, why haven't you heard of it? You went to school for 12 years, maybe more. You learned the water cycle, evaporation, condensation, precipitation. You can label a diagram.
But nobody ever told you that your great-grandmother's kitchen had running water before her county had electricity, and the system that delivered it is still sitting in the hillside behind the old farmhouse, rusted over, forgotten, but structurally intact. The answer isn't a conspiracy.
I know that's not as satisfying, but it's the truth. And this audience deserves the truth more than it deserves drama. Rural electrification changed everything. Starting in the 1930s, the Rural Electrification Administration brought power lines to farms and hollows that had never seen a light switch. And with electricity came the electric well pump, convenient, consistent, and independent of whether you happen to have a spring on your ridge. Municipal water systems expanded through the 1950s and 60s. Suddenly, you didn't need to know where your spring was. You didn't need to understand head pressure or pipe grade. You just turned a tap and paid a bill. The knowledge didn't get suppressed, it got unnecessary. And unnecessary knowledge doesn't survive a generation. Your grandfather knew it. Your father half remembered it. You never learned it. That's not a plot. That's just how convenience works. It replaces competence, one generation at a time, until the competence is gone.
But here's what nobody in a utility office will tell you. The springs didn't stop. The creeks didn't stop. The hills didn't flatten. Every condition that made these systems work 100 years ago still exists on millions of properties across this country. What vanished was the knowledge, and knowledge can come back. If you have a spring on higher ground and $200 worth of pipe, you can have gravity-fed water. If you have a creek with decent flow and a few feet of fall, you can build or buy a ram pump and push water where you need it. You'll need to check your local water regulations. You'll want to test the source water. Spring water is often clean, but often isn't always, and a $50 test kit is cheap insurance against bacteria or mineral contamination. You'll need to think about winter protection in cold climates. None of this is plug and play.
But none of it is beyond a person who's willing to learn. And the fact that you're still here tells me something about the kind of person you are.
Let me leave you with this. Somewhere in rural Pennsylvania right now, there's a pipe coming out of the hillside. It was laid before the moon landing. The spring behind it has been flowing since before anyone alive can remember. No one checks on it. No one maintains it. No one pays for it. The water runs because the hill is there and the spring is there, and the pipe connects the two. That's the whole system. And when the power goes out in the next county, when the well pump stops, when the generator runs dry, when the bill goes up another 12%, that pipe doesn't notice. It doesn't care. It just keeps flowing, the way it always has. 70 years now, maybe 70 more. And the only thing that ever threatened it wasn't whether or where. It was forgetting it existed. You're not going to forget.